And we're recording. Hi, Stephen.
Hey, good morning. How are you?
Good. We're going to try to redo this. We got 50 minutes, so we got to move fast. But I think we should talk about what's going on in August of 2024 with AI. There's a lot going on.
There is a lot of movement, a lot of conversation, and some disagreement too.
Oh my God, it's crazy. Um, I should just comment. Some of these slides are a little out of date. They were done at the end of June, and July rolled by. But the general shape of what we're going to talk about is clear, and we'll probably do some light updates on the slide. So for everyone who hasn't kept up with us, we've been doing this since June of last year, and we do a regular predictions and what happened over the last period. And my new co-host is Stephen Gottlieb. Hello, Stephen.
Hello, hello.
How are you doing, Steve? But
I'm good. I'm good.
Dion is off busy doing things. Paul is in Egypt. People are everywhere. So, but hopefully, Stephen and I will be part of the regular crew going forward.
We're the only ones maybe really working in August.
Yeah, we're crazy. So let me just talk about what's going on. And I just want to tell you that this is all from our little company called Total Neural Enterprises. And we have what we call the Diamond Team, which is looking at the state of the art. We build applications, we build systems for AI. And everyone listening to this is part of what we call the AI Hub, which is how we communicate all these great things with all our friends. So you're getting it straight from the horse's mouth, if you will. So just so you know, this is part of a series. We have a YouTube channel, of course. We also have a private WhatsApp group, but there's histories and intuitions that come before this, which just, if you know nothing about AI, just give you some ideas. This is really about developments that have just happened. And Stephen, it feels like every day there's another thing happening.
Every day.
Every day. And then some predictions about what's going to happen over, I used to say a year. Now I'm sort of like 3 months. So first, an apology. It's really hard to keep up in this technology blizzard. Not only is there a lot going on in the tech world, but the business world is changing like crazy. So I think the big thing is, I should probably comment on this. There are a lot of papers coming out. So there were over 11,000 papers actually back in July of last year shipping. And so we're just trying to keep track of all this stuff. And you can see this is the history of papers published per year since 2004. It's quite a crazy blizzard. Now, most of these are junk, Stephen, but it's nice to know that we're doing this so you don't have to.
Correct.
So remember when we first showed this slide, the AI disappointment slide? Seems like the press is talking about this a lot now. We've seen a couple articles about how people are disappointed in this. Kind of the usual thing. You know, you and I have been in the industry a long time, don't you think?
I do, and um, I think that there's clearly confusion, and there may be um, a conflict about expectations and time horizons.
Yeah.
Um, I think your characterization of a technology blizzard is right on. I think before there is true accepted transformation, it is a blizzard, and this is not something that we're gonna realize fully in weeks, months, or even a couple years.
Yeah. Oh,
Um,
yeah,
and,
absolutely.
and so, we're looking decades till we see the full impact of what we're experiencing now.
Yeah. Yeah. Decades would be generous. But I think that it is true that there's a lot of hype. You know, this is the Gartner curve from last year, and generative AI is at the top. And this is the normal curve, and hopefully we can help people flatten the curve out a little bit. That's the
Mhm.
main idea of this podcast and this call. So let's talk about what's in store for, not 10 years, maybe a year, maybe a month, maybe just a week, because things keep changing. So I think in a nutshell, we've seen four trends. The first is uh, these large language models, just the refinement is on steroids, right? Most of the proprietary models are now up at the GPT-4 level, like OpenAI. So there's been a tremendous compression of things. And the open source models, like Llama 3 400B, which just shipped last month, those are huge, right? Because it means open source models are within 5% of proprietary. And I think the big news from the Apple Developers Conference and the Microsoft AI PC thing is it's no longer a dream to have these things running on desktop and mobile devices. So for the first time, you can actually imagine with things like Apple Intelligence that you can have client-only AI. You don't need gigantic NVIDIA processors. Don't you think that's a huge deal?
I think it's a huge deal, but I guess my question is the mechanism or the approach to getting the data to train these models
Oh, yeah.
in an appropriate manner. You and I were talking just before we started here about the recent NVIDIA news from earlier in the week around that there is some concern that they have broken some agreements with Netflix and YouTube by scraping huge swaths of data without consent to try to train their models.
Yeah, I
So
think,
how,
don't you think it's one of the saddest things that we are in a position now where gigantic companies who are top 5 market cap feel the need to basically violate a lot of these rules? And I think it's sort of hilarious that OpenAI can neither confirm nor deny whether or not they copied YouTube videos. I mean, how can you not know this?
right? And doesn't that, I mean, but I guess what I'm getting at is in this blizzard, are there activities that are being performed that are not in keeping with appropriate business principles?
Well, I
And
think,
so
yeah.
so no, go ahead. I'd love your input
Oh no,
because
I think
if we're
there's
gonna if we're gonna have an AI
yeah,
on our phone, we need to be everybody needs to be sure
yeah.
that they're accessing data that is been used properly, collected properly.
Absolutely. I mean, I think there's such a temptation in this capitalistic world to break those agreements, and privacy and making sure your data is your data and what's on the firewall stays on your side of the firewall is one of the big concerns of our times. I think there are ways to do this legally. And I think that this is a case where regulation and us as consumers favoring companies that respect privacy is super important. I know Apple's made some strong statements, for instance, that none of the data, training data, goes to OpenAI because they have a deal with them. I think we really need to be aware as consumers, as enterprise customers, that we hold these companies to the highest possible standards. Don't you think?
Totally, and I assume, I assume as we get through these slides, so much of this is about education, but part of the pace um, requires a certain kind of education, and that can also slow down people's understanding and true acceptance
Oh,
because they're learning something new is on the fly.
I totally agree with you. I mean, I think this is the point of this whole thing is for technical people, business people to be educated enough to ask the serious discerning questions about large language models and everything else. We all need to be smart about this because
Correct.
the changes are huge. And by the way, it's going to
Correct.
get worse because if you look at the next point, hey man, it's not just text anymore; it's sound, images, everything else, right? The IO revolution is accelerating, and there's going to be a reasonable expectation, I think, of privacy for the images that if you're a photographer, you're producing things. If you're an artist, if you just make a video on TikTok, what actually happens to this data and who's using it? So I think this is a really a big important issue. And remember, the next part of this revolution is these AIs can just read websites and computer screens, right? We're getting quite close to that. And then we have virtual reality and robots, where robots are going to be running around. So the impact of AI on our lives is going to be huge. And so this understanding is very important.
And this is why these AI hubs we're doing are so important because it is ongoing, iterative, real-time learning that we're trying to pass on.
Yeah,
So
yeah.
absolutely.
And I think that's important. The other thing's important is, which comes up on the third major point, is last year the focus was on one big large language model like ChatGPT solving the world's problems. Literally, it was like, please make me money. Here's my Venmo account, and you expect money to pour into your wallet. That didn't happen, ladies and gentlemen, because it's actually really hard to program these things. And I think the big news for the first half of 2024 is big large language models are nearly impossible to program and control. And so there's been this shift to small large language models, if you will. These are easier to control. They're called agents, where little large language models sort of get connected together and you can control those things. And I think that is sort of the big news on programming. It also means they hallucinate less. And they're much easier to develop. So that's the big news. which basically means that large language models, as they refine, as they get more I/O, we can actually harness them. I will comment that the so-called planning, like what I should do, remains the big Achilles heel. So GPT-5, the much rumored next version, is supposed to focus on planning and searching and trying to find answers. And you can see this all the time. You know, I type a chat prompt in, it just sort of loses the plot. Right, that's a huge problem. And the last thing is, of course, you know, you and me as end users or as enterprise customers, you know, we're just drowning in this world of promise versus delivery. So every website, if it doesn't say we're completely AI enabled, it's like someone forgot to add it to the WordPress site. I feel like there's almost a template, right? It's like, and we are an AIX. But the information flow is super low. There's such a mountain of work to turn an interesting paper into something that's actually useful. And what's happening is we're getting a lot of try rejectors. So a Gartner study recently said, I think it was Gartner, I can't remember. Someone recently said 1/3 of the AI trials are failing because it makes it like a great prototype, but it really doesn't work. And so that stuff is really hard. That last 20% is really hard to get right. Yeah.
Are there examples of firms or companies that you think are right now getting that last 20% right?
Well, I'd like to think our customers are getting it right, but I think most of the folks that we see, they're starting small. Like, you know, they have a small chat bot that does a small thing. This idea it's going to change the entire world in one step, I think, is what people are finding is not true. And the key is just a prototype, right? And I can't emphasize this enough. We're seeing everyone saying the area is too new. You got to hear the requirements, show something small, and then you can be successful. So instead of trying to completely fire everybody, the key is to try one small experiment, make sure it's under control. Most of the people we see are using them as assistants to help people be more productive, as opposed to, you know, this terrifying fear that it's just going to replace all our jobs. That could be true in certain segments. I think most of the folks we're seeing are much more controlled about it because, you know, hallucinations, which we used to in the old days call it a bug, is a real problem. Yep. So why don't we dive in a little bit and talk about some of these trends? Going. Yeah. So we're going to talk about 8 diamonds in the rough. Our dog friends always think this is a hilarious pun, so I'm going to leave it here. But basically, we're going to talk about 7 technical diamonds that are happening, and then one that's about the industry and customers. That's sort of our whole presentation. We're going to be shorter today because we don't have as much time. So we'll just talk about probably 5 because that's what we have time to talk about. But the biggest one is the thing we call a chatbot isn't really a chatbot. It's an emerging operating system that combines agents together. This is a really important idea. It's not just a bot you talk to, but it's a completely different architecture for the way we write software. So Andrew Karpathy, back in November of 2023, which is ancient history, being almost 10 months ago, said, I don't think it's accurate to think of a large language model as a chatbot. It is a lot more correct to think of it as the kernel process of an emerging operating system. And he actually did this diagram, and it says, well, here's the LLM, and it has all the characteristics of an operating system. It's got input and output, it can read audio and video. It's got the ability to run calculations. It has a file system. It has the ability to call other large language models, talk to the browser. This whole thing is a lot of different functions. It's not just taking text in and text out. And so when you think about what's emerging, the second thing that's emerging, which just happened in March of 2024, is even when you take that operating system, it's not controllable enough. And Andrew Ng, who's one of the revered, also from Stanford, great thinkers in this, said, we mostly use large language models in zero-shot mode. This is akin to asking someone to compose an essay from start to finish, typing straight through with no spacing allowed and expecting a high-quality result. How can you possibly expect that to work? And then he did a picture talking about an architecture, which he called communicative agents for software development. I'm not saying that's a good term, but that's what he used. And he just points out that you can also think about the way companies are organized. There's a CEO who's got a job. There's an assistant. There's CTOs. There's CEOs. And they have this conversation to actually get to a final result. And this is, I think, a much better way to think about how to build models, which is each of these small large language models has a specialization. One understands technology, the other understands products. And you keep going from a high level to a medium level to testing to documenting. And so you basically have the same kind of flow that you would have in a company. And he calls this the agentic workflow. So all of this boils down to a different way to think about the way you build things. Jensen Huang. Sorry.
Let me just ask a question. Is this akin to rethinking that we're not building apps or specific products, but this AI effort is building really a full platform operating system of which you can snap on top?
Absolutely.
Exactly what an enterprise organization needs.
Yeah, you can think of these more like building blocks, like traditional software, as opposed to one mumbo jumbo thing. And in fact, Jensen Huang just in July said, Microsoft created a revolution by packaging all that software up. We need a packaging for the AI factory. And he talks about their model for having a standard AI model you can just download to your PC and connect to other large applications. So people are already thinking about taking those agents and packaging them up. Now, of course, with NVIDIA, these agents only run on CUDA in their system. And some people may find that limiting, but you can see where everyone's headed. And I think the biggest thing for everyone listening to this is, how do you want to participate in this world? How do you want to build modules, also known as agents? How do you want to package those things up for reuse? So the other way to look at it is just as a computer techie. In 2023, the AI architecture was what you might want to call, it's just magic, right? So you chat to a gigantic thing called GPT-4. It reads text. It produces output. Pretty simple, right? It's just this gigantic black box. You might write a little code in LangChain. You might have some prompts. You just use Azure. I wish this could have worked, Stephen. This would be so great. No work at all. You just type a few words in and you mint money. I'm sorry to report that it's going to be a little harder than that. So this is one way to think about the new architecture, which is instead of one thing, you have to create a lot of these little agents, these reusable modules. They need to take in not just text, but files, databases, other code, multimedia. They need to process it. Other agents do intermediate work. There needs to be a planning agent in the middle to tell you what to do. And then you got to produce real output, not just text goes ta, but a real memo or logging data or multimedia or ultimately controls for robots. So it's a much more complex architecture, much harder to control. And that requires 4 things we haven't seen yet. And the first thing is a real development environment, because now we're in programming, not just typing text. You have to have a way to test to make sure it works, et cetera, et cetera. You have to have a way to reuse this stuff, because why reinvent the wheel all the time? By the way, these things mean a lot of things are running, so you need some operations, right? You need a way to say what's running, what crashed, where are things running. And then finally, let's face it, just typing into a chatbot is not a user interface, right? You're going to need a way to talk to it. You're going to need a way to write applications and so forth. So pretty complicated, don't you think, what we really have to build?
Absolutely.
Yeah. And so
absolutely. I mean, people, we're learning and building on the fly.
Yeah, exactly. And just to, it's not a commercial, but just a comment. This is what's been driving up us at Total Neural Enterprises at TNE.ai. What's the right dev environment? What's the right reuse model? E.g., what's the right library? What's the right distributed kernel to run these things? And how do you build a flexible user interface that an LLM can directly control? Those are all important modules that I think will be very important to stitch together and make work together. So enterprises can make a total neural engine for their business.
Totally understand.
So that I think is the overall thing. Let's talk about the central thing, which is what are these LLMs? And I would just say, eureka, it's raining large language models, man. We thought there was just one, and now there's a lot. So I can't emphasize what an explosion this is. This is an eye chart. You can look at it on the YouTube thing. These are the announcements, the big 2023 announcements. In the first half alone, these were just some of the major announcements. And you can see the volume is just doubling. In fact, certain weeks, there were actually 2 to 3 major announcements every week of major large language models. And this evolutionary tree, which started simply in 2028, has gone totally crazy. So we're up here on the upper right, and literally there's a new model happening every week. that is a contender for a large language model you might want to use in your company? Just look at this, Stephen. This is
And
crazy, isn't it?
I know. It makes me wonder, like, are we ever going to run out of data to pull from?
Yeah, well, the forecast is we're going to run out of data in 2 years, and the real answer is going to be there's all this information that lives behind the firewall, things that are not on the public internet. That's where the gold mine is. We don't want, anyone to get access to your data. So I think there's a real opportunity for every company to take their private data, create their own large language models based on these, and really become everyone has a chance to become an AI monster. I think that's a huge opportunity for everyone, don't you think?
Absolutely. So the competitive landscape is going to drastically evolve and change
No,
as we move forward.
yeah, there's a real opportunity where your name could be up here. Your company name
Mhm,
could be up here, building a model that works specifically for your industry.
mhm.
And of course, we'd like to help make that true. The other thing I want to say is if you look at this chart is the same chart, but it shows the size of the model. So that's the size of the chart. And then when it was launched. And what you're seeing is at the beginning, there were just a few models. Sorry, there were just a few models. And look at this explosion. Not only there are a lot more, but they're like from gigantic billions of parameters to tiny. So there really is a large language model for every occasion. So what does that mean? Well, it means that some of these models down here, they can run on your phone. So you can have models that
Well,
run small to big.
so from a user or business perspective, how do you identify what LLM you should be using or accessing for your own needs?
I'm so glad you said that because I just got a call from a very smart CTO, and his question was, we've decided to pick Model X for all our use for the rest of time. And my response to him is, I think making this decision is not the smartest thing. You really need to every time look at all the different models that are out there and make a decision, what's the right model for the job, right? So you're going to be picking from a huge cornucopia. That's actually good for all of us, right? There's not going to be one company that has a hegemony over the entire industry. You should pick and choose and then make the right decision for you and make sure you don't get locked in.
Great.
The second thing that's sort of amazing is we're going to talk about Llama. So Llama is the open source model that Meta has announced. They did Llama 3 sort of at the 6 or 7 months ago, and Llama 3.1 just shipped with a gigantic new model called inventively Llama 3.1 400B. And what you can do with those is you can actually take those models and you can fine tune them, e.g., make them customized. So the chart on the left, the Hugging Face is where all these the sort of the central repository. So these custom models based on open source, there were 500,000 in April. There were 600,000 in May, 700,000 at the beginning of July. Stephen, you want to guess how many models there are right now?
No, I don't.
Close to 800,000 models. So specific models just tuned for certain occasions. So it's a free for all. So it's not just the base models, the base foundation models, but all of these fine tunings. And there's definitely a model there for you if you can find the right one. And, just again, that's one of the key things we're working on. Of course, Stephen knows this. Pick the right model for the right job. Don't just pick the model that you know, because you can save a lot of work if you pick the right one. These other two charts, it's interesting. There are now aggregators that take open source models like OpenRouter and Replicate, so you can pick the lowest cost one. There's a Reddit called R Local Llama, which basically is taking open source models and putting them on machines, small machines. That particular Reddit had 100,000 people, was in the top 5 in January. By June, it had 175 175 users. Interestingly, it was in the top 1% of the most active Reddits of all time. It just shows you how much information is now flowing. We all, as enterprise people, realize taking advantage of this momentum is what really made Linux what it is today. It's what made the open source community what it is today.
So let me ask you a question here, because of your the experience you've had over the last 30 years. Is there a comparable technology blizzard or transformation that is analogous
Oh, I
to
think
what
there's,
we're experiencing, and are there lessons learned that people can grab onto to help clarify what we're working through now?
well, I can talk about two that I was personally involved with. I can't believe it's been 30 years, by the way. It just seems like it was yesterday. But back in the day, I worked at Microsoft and worked on a little product called Windows. And, Windows at that time had a dominant share of everything that was running. And what happened was a guy named Linus Torvald created a small little open source version of Unix called Linux. And today that core is at the core of most cell phones and Android. It's at the core of most servers that are running on the internet. And the reason was literally millions of people contributed software that ran on Linux. And if you look at the guts of, say, Apple system or even Microsoft Windows today, you'll find open source components that are derived from that. So it's a good example of how typically in these markets, the proprietary systems come out, they have an early lead. It's sort of like a signal to everyone in China, Bulgaria, Kenya, it doesn't matter where, that it's possible. As soon as that's possible, people say, how can I reinvent that in an open way? So today, by far, Linux is the dominant operating system if you look just in terms of units. The second thing
Great.
is I was part of, working in venture capital at the time here in the US and in Asia. The first mobile operating systems, there was Nokia, there was Microsoft, there was Apple. If you look today, by far the dominant operating system in the world for mobile in terms of units, not in terms of revenues, is Android, right? Which started the same way. It was a project. It actually started as a set-top box interface for Google. Google open sourced it. And today, most vendors, other than, of course, Apple, use Android as their core operating system, right? And again, the same thing happened. Amazing creativity, amazing openness. I don't know what's going to happen in the AI world, but it just goes to show you that when you have, it's really nice to have 100,000 people in your company. Super nice to have 1 million software developers working for you on the internet. And in fact, Meta, who's been at the leader of this movement, Mark Zuckerberg actually did a manifesto, and he said the biggest reason Meta is open sourcing Llama 3 is because taking advantage of all that will just benefit Meta in the long term. All these innovations people have, and I'm sure 1% of these, 99% of these models are terrible, but 1% are amazing, right? So there's 7,000 amazing things that have been done, and that can be brought back to people. So this porousness between the open community and the closed community is what's made a lot of these companies great. I've been amazed at how Google has taken certain open source initiatives and brought them back into the company and then brought them back out again. Apple, it's not well known, a lot of the core utilities inside Apple are actually from that Linux community. And in fact, the Apple core, which is called Darwin, is actually open source. The bottom of Apple's system is actually an open source project. So you have to remember these great companies. And Windows, of course, is done the same thing with Windows subsystem for Linux, having the founder of Python in their company. So it's just that interchange that's going to be important.
Right. I know we want to get on the other slides, but what you're really saying is that when we look back at this period of time, there's going to be similar DNA that we've experienced in those two examples that you just gave.
Yeah, I mean, who knows? I mean, I think Paul Moritz, who's one of my godfathers in terms of thinking things. He was the CEO of VMware, the number 3 guy at Microsoft, said the next 12 to 18 months are a zone of high uncertainty. So I'll leave you with that. So this is just a guess. It could be something different, but if the past is indicative of the future, you might see open source becoming a bigger part of every enterprise's life.
Great.
So I wanted to highlight this. Now, this is a little bit different, so I just want to explain what it is. So there are a lot of tests to see whether a large language model is good or bad. I can go through all of this. This one's a little bit unusual. These are just humans typing things into various systems and saying, oh, I look at the GPT-4, I look at Claude V1, which one do I like better? So it's not definitive. It just says, how natural are these chatbots? There are a lot of these standard types of tests. But one of the things I like about this test, which is done by LLMsys.org, is that you can't game it. It's just random humans typing things. So it gives you the non-game view. Not to say people are gaming things, but if you have a fixed benchmark like MT Bench, awful tempting to tune your model to do well on it. So this is sort of the open thing. Now, what this shows is back in June of 2023, this uses a chess rating system. So if you've ever played chess before, there's a rating, everyone gets one. It was done by Professor Elo, who invented it. And what it means is, this is GPT-4 at the time had a 1200 rating. It means that if you're 100 points lower, right? So if you're at 1111, GPT-4 will beat you 64% of the time. It's not always going to beat you. In fact, a third of the time, that poor model will actually win. So it just gives you a sense of how close these things are. And what you see looking back a year ago, the only models that were within close to GPT-4 were the private ones. Anthropic made Claude V1, there's Claude V1 Instant and GPT-3.5 Turbo. So essentially only 2 companies in the world were able to keep up with OpenAI. The nearest open source one was something like Kuna 33B at 1196, right? So it just goes to show that back a year ago, the prediction was, man, no one's going to be able to keep up. So let's just fast forward 1 year and see where we are. So this is June 2024. These numbers have actually shifted a little bit. So for instance, the thing that's called a Gemini 1.5 Pro is actually leading. So it's the best model. But it shows that GPT-4 Omni, GPT-4o, is at 1287. But look at all the models that are within 100 points. Isn't that incredible? So it went from only 2 companies being within the top 100 to all top 20 models being in fighting range of GPT.
So we have choice and we have competition.
And that's the best thing for all of us, right? Because what it means is that you have a lot more to choose from in these base models. I'd also want to point out that these models are much more efficient. So one of the models here is Llama 370B. That's only 70 billion parameters. We don't know what GPT-4o is. The speculation is probably between 500 million and 1.3 trillion parameters, but that's a much bigger model than Llama 370B. By the way, Llama 370B you can actually run on a big laptop. So it's a huge change to have some that could run on a laptop, be competitive. I'd also note it is a global phenomena. So 4 of these top models are actually from China. So you have to just be aware that there's a global competitive thing happening as well. So Quen Max is from China, Yi is from China. So this competition has definitely become democratized. There's more to it than that, though, because there are just huge differences in performance. So remember, GPT-4o is that leading model. By the way, these prices were as of June. The price of GPT-4 has been collapsing because there's been such competitiveness. And you wonder why? Well, it's pretty obvious. Remember that pretty good model, Llama 370B? It's 64 cents, right? So if you take 64 cents per million tokens in, 64 cents per million tokens out, pretty hard to maintain a $15 per million tokens thing when something that's pretty decent is 200 times cheaper, don't you think? So that's good for everybody. It means that open source is keeping these models honest, right? And we really want that because this kind of performance difference is huge. So just to give you the overall difference between the top and the bottom, and these models are all within that 100 points, there's a 71x difference in the June pricing, 204 times difference in output. By the way, small models run faster. So latency-wise, the time to wait is 4 times less for these models, and they run 4 times faster. So these things are huge differences if you're trying to build something. The chart, by the way, below shows actual latencies for OpenAI. And, you know, these things differ, right? There are differences in performance and speed because it's running a big model in the cloud. I'll just do one techie thing for a second, Stephen. This is because these large models, they're heavily dependent on something called batch size. So think of it this way. To run a query, to run Stephen's great query through, it has to wait for 127 other queries, and then it pushes it in through, right? Because it would be very inefficient to just run Stephen's favorite query in one at a time. So you're waiting for these buses to kind of get through. So a lot of these variances could be as simple as, I just ran out of GPU storage space. By the way, the rumor is OpenAI has 300,000 NVIDIA H100s serving us, but you can still run out. Or it could be just that the bus is empty and is just waiting for the next guy to get on. Because performance varies in these cloud models. These models that run on your laptop, like you don't have that problem, right? You know, Stephen, you're the lord and master of your laptop. It's ready there waiting for you. So you got to remember that. And so We see this all the time on websites. I was just on a website that should remain nameless, and it said, "We're too busy for users." There's no magic for LLMs. Have you ever seen these kind of latencies or problems, Steve?
No,
Yeah, you're lucky, super
no.
lucky. We use it every day. I see this all the time. Super frustrating. Okay, but here's where it gets worse. Remember, those were just base models. Remember I talked about those fine-tuned models? Turns out that this is an example using something called fine-tuning. And what that means is that you can take an 8 billion parameter model, which scores 67 on this particular benchmark. Someone went and fine-tuned it, and they got it to equal to the performance of 70B, right? So they went from 67 points to 75 points just by fine-tuning on this benchmark. So not only is it true you got to pick the right base model, but there could be a fine-tuned model that works well here. Now, there's no such thing as a free lunch. What it probably means is on every other benchmark, it's way worse. But if you have an agent that only needs to, say, process databases or answer questions, it can forget about everything it knows about Taylor Swift. Remember, all these models are trained on the internet, so it's carrying around all this knowledge about who won Bruce Springsteen, who is Bruce Springsteen, who are the Olympic skydive medalists for the ski medalists for the last 40 years. You just cut all that out and the model performs much better. So a fine-tuned model, you can fine-tune a small model and it can outperform, it can get to the same performance as a model 10 times bigger.
So
that's another variable.
It's a form of editing and refinement.
Yeah, I think about it. Yeah, exactly. I mean, it's sort of like my brain is only filled with facts about spreadsheets.
Right.
Yeah.
Right.
Yeah. And of course, getting through this is pretty hard. The other thing that's interesting is just remember a fine-tuned model. That if you have a fine-tuned model, a lot of times you don't need GPT-4. So this is a real-world example from one of our customers, and we ran the same query through GPT-4 Turbo and through Llama 370B. And I'm not going to take you through this whole thing, but our conclusion is actually Llama 370B has the better answer, right? And it's a very detailed thing about actions in the code industry and so forth. But if you were to read through this thing, our business analyst said, I like the Llama 370B thing better than GPT-4 because it's been fine-tuned, right? So this is a real-world example where with the right planning and the right agents, 70B is perfectly acceptable. It's 100x cheaper to run and it's 4x faster. By the way, there's a model called Llama 3 Mini 4B, which is a great name. It's a Microsoft model that actually can run on phones. And our early testing shows that its results on this are perfectly acceptable, showing that you can really tune these things up to get great performance. And it doesn't take much time. By the way, the model tuning we did here was about 15 minutes on a GPU just to tune it up. So it's not like it's a huge task, just a little work and you can really get great performance. Make sense? Yeah.
Yes.
Yeah. So, and here it is. So this is the race to on-device and what we call ordinary server LLM. So Apple has got something called OpenELM, Apple Intelligence. What they're basically doing is running 1 in 3 billion parameter models and smaller on the next generation iPhone 16s. This example on the right was actually run on an M2 MacBook Air with 8 gigabytes. So this is a 3-year-old machine and it's running that same calculation as before. And I'm not going to take you through it, but this result is perfectly fine. Right, so what that says is we can take this model, it just runs on a laptop from 3 years ago. Implication is Microsoft is right there. They've got an initiative called AI PC, which basically means you're going to see ordinary PCs that can perform just like this, that'll be available for ordinary humans sometime probably in the next 6 to 12 months. They've been announced now and they're shipping soon. And Gemini Nano is already deploying onto Google Android machines. Since this slide sheet was done in June, Google's also deploying a version of Gemini, which is their system, on Nest thermometers. Think about that, right? So in the old days where we thought it'd only be big cloud machines, man, this stuff is just going everywhere, right? The third point is a lot of these things run on the very latest NVIDIA hardware, the so-called H100s and 200s. There's a new version coming out that just got delayed a little bit called Blackwell. These are machines, by the way, that cost $25,000 per GPU, cost $250,000 for a rack, and over $1 million per full data center system. So these things are unbelievably expensive. These non-H100 systems, like I won't go through the whole specs, but an RTX 5000 costs $20,000. You can order it today from Dell and be delivered in 3 days. So these are machines that are completely ordinary, don't require you to know Jensen Huang's email and have a meeting with them. You just get them off the shelf. Big deal for companies, don't you think?
Yeah, unbelievable.
Yeah. So I think that's one of the untold stories. A lot of people are saying, there'll be big companies say, I'm just going to wait for Microsoft, just like people used to wait for IBM back in the last century. But if cost is an issue or vendor independence is an issue, this is really a big deal. Okay. I'm going to get farther down and deeper in this stuff, but let's talk about large language model internals. Now, Stephen, I don't expect you to get this as a business person. This is just sort of at the high level. With the more technical people, let's talk about why these improvements are happening. It's not like just magic, right? It's not like just you made something happen. All those improvements you saw in diamond number 2 are because of the changes happening here. And I would also highly encourage people who don't understand this, look at our intuition section to get some feeling for why this is happening. So I'm just going to go through a very basic architecture and explain what's actually going on inside a large language model. And the first thing to understand is, when you get text, you don't actually get text into the system. You get something called an embedding. And an embedding is this really interesting idea, which is like the word Stephen, right? And the word rich, they don't get the letters STEVEN. They actually get a vector. It's typically 1,500 dimensions wide. So 3D is like 3. This is 1,500. I can't even imagine it. And the word rich is also 1,500 dimensions. And the key thing about embeddings is if you take the embedding for the word Paris and subtract the embedding for the word France and add the embedding for the word UK, you get the embedding for the word London. Right? Truly remarkable. And what's happening is inside the embedding for Paris is this idea of capital and the idea of the word and the idea of country somewhere in there. And so when I subtract country, all I get is capital. And when I add UK in, I get what's the capital of the UK. And so that is really the magic of these large language models, which is how these embeddings work. No one ever talks about it, but picking the right embedding is actually the key. And some people say embeddings are actually the key to what makes large language models work.
And isn't the embedding an attribute of speed?
Yes, it's an attribute of speed and also of the data corpus you have. So for instance, you can change the embedding so it only knows about things about your business, right? So you could theoretically take competitor 1, add a country and subtract another country, and you get all the competitive data for the second country, as an example. So that embedding thing is very important. Some people speculate, by the way, this is actually the root of all human intelligence. You think about it, when I think of Stephen, I think a lot of different things. Cool guy in Denver, smart business person, great dad. All those things are attributes of Stephen. You're just not a one-dimensional thing.
No, but there's a connection, or there's a relationship to what you're saying and how our own brains work. We do our own form of embedding,
right?
That it is hard for us to articulate, but we do it.
That's right. And I think if you were to go to our podcast about that, Yoshua Bengio, who won the Turing Prize a couple of years ago and is one of the 3 founders of AI, said, I have a speculation. This is the basis of human knowledge. That really what we're doing is storing a deep embedding. I had a chance to talk to your son, right? There are a lot of attributes, right? Smart kid at Northwestern, Stephen's son, need to find him a great job, et cetera, et cetera. And all of that is embedded in that concept of your son, right?
Correct.
And so that's, I think, what you have to understand, that that is where a lot of the intelligence comes from, this embedding thing. The second thing is this idea of context, which is simply put, and by the way, embeddings, we can thank Google for this. They open sourced the paper about how this works 4 or 5 years ago, and everyone's followed it. So great gratitude to the folks at Google. The context buffer is the second thing. When you type into ChatGPT, there's a limited number of things you can say. This is called context, right? And this is a classic thing. If I say, hey, Stephen, what's the third paragraph after the last one? You can probably find it. If I say, please, Stephen, read the entire Library of Congress, please tell me what's in shelf 32. I know you can do it, Stephen. I might have some trouble remembering what's on shelf 32 in the Library of Congress. And so this concept of context is how much stuff do you have to look at? Some people, in the computer business will call that RAM, what's loaded. And the concept of attention is the idea of what should I pay attention to if I'm in a large language model. So when I say book, shelf 32 in the Library of Congress, my attention should move from all those other books to just the books on that shelf, right? Just like when I say time to do a podcast, I can literally feel myself throughout all the things about I got to, what am I getting for lunch and so forth, moving to how do I get Open Broadcast Studio running? What's the Zoom call for this call and all these other things. That's what attention is. So attention is all you need. Actually, that's what a lot of these improvements have been focused on. How you do embeddings, making a bigger context buffer, and how you get better attention as things get longer. So it's actually reining attention. So ChatGPT, by the way, a year ago, it could basically handle 4,000 syllables. That was it. So if you fed it in the Bible or whatever, it'd say it's too much. The new models actually have infinite attention. We've gone from 4,000 to 8,000 to 128,000 to 1 million to you can actually load in everything in the world and you can actually processes it, which is kind of amazing. The Llama 3, for instance, handles 128,000 tokens. That, by the way, from your latest, I just did the calculation. It's basically the last book that you worked on, Stephen. You could get all that, and theoretically, you could say, what's on chapter 2, and it would know where it is. Whereas before, you could handle basically 2 pages. And the way that that's working is actually quite magical. So 2 things happened. The first was in 2023 was all about hardware optimization. Some brilliant people, again at Stanford, figured out that the way that you looked for things in RAM was inefficient, and they basically did a bunch of magic we're not going to talk about here, but basically if you saw something previously, don't throw it back out. And this chart shows just the memory hierarchy. So GPU, that's an NVIDIA, it has something called static RAM. It's only about 20 megabytes, but it runs at 19 terabytes per second. Then it's got something called high bandwidth memory that runs at 1.5 terabytes per second. That's 10 times slower. There's 40 gigabytes of that. And the DRAM is 12.8 gigabytes per second. So if you throw something that you need to pay attention to out the DRAM, if you say every second is a tick for SRAM, you'd have to wait a year for that data to come back from DRAM. Right, think about that. Actually, it's actually about 3 years. So you got to be really careful about what you put where. And all the work in 2023, a lot of it was, where is this stuff going? And flash attention, which is the technical term, was basically a scheme for being really smart about this. And that actually resulted in massive improvements in performance. There was something called softmax that did the same thing. Paged attention was just this idea of what you page in and out. So it was all hardware based. What happened in the first quarter of 2024 was something called ROPE, which means relative position encoding using an embedding vector. I can't go through all the math. I have to tell you, Stephen, it is so elegant. What they basically do is this shows tokens from 0 to 4,000, and they basically encode a vector that says in one number about where it is in the buffer. So if you had the word Stephen Gottlieb, it said, well, I've got the word Stephen Gottlieb here, and it's also on page 3, right? And so that basically allowed better interpolation, and that's what something called long rope extends this particular technique to 2 million tokens. The math on this is highly complicated. You don't need to understand a lot of it, but that is the magic. Mathematicians and hardware experts, that's what's happening that allows all this magic to happen.
So Rich, I know we're coming up on time, and I know we have a lot more to go through. Are there certain highlights that you want to hit on here in the next few minutes?
Yeah, well, what we'll do is we're trying to make this just an hour long. My last one's an hour and a half. So I think the highlights are, number one, big change in the way you structure large language models when applications from a big one to a small series. And the second thing is that picking the right model is no longer just picking one model. It's going through this whole catalog of hundreds of thousands and finding the right base one and then fine tuning it. And then let's all give a real appreciation to all those nerds out there who are grinding away, trying to make everything three times faster. Because soon we'll be able to do all this on your phone, my phone, and on your desktop.
Terrific. And I on our next podcast, I know you're going to run through new information, new data, new predictions, but I think it'd be valuable to talk a bit about the role of human capital.
Absolutely. We'll definitely do that.
In terms of the skills that are needed to build these LLMs, but on the business side, the human capital that's needed to actually understand and deploy. Because earlier we talked about, this is all being learned and built at the same time. So I have to imagine that there are human capital issues here inherent on both sides, both the use and business side and the creation, innovation, coding, algorithm side.
Yeah, I think none of us need to worry about losing our jobs. We need to think about retooling ourselves for essentially doing AI programming and implementing AI systems, but there needs to be a sea change in business thinking, in technical thinking, and in programming and operations. So no, let's make sure to cover that next time, Stephen. This has been great, by the way. I've really had a good time talking with you. It's our first time experimenting, working together. This is total live, right? No editing. We're just jamming. Yep. And it's been
great.
Yeah, we're gonna have a good time doing the rest of these.
Great. I look forward to the next one.
See you, Stephen.
Thank you.
Bye-bye.
Bye.